everybody. My name is Badaruddin. I am the CTO of GetGo Technologies out from Singapore. And today for the EDA Summit, I'll be talking about navigating out of a monolith into an EDA quickly, given provided by Solus, a solution provided by Solus. So let's start off with a little bit of an introduction. So we are a car sharing company out of Singapore, and we have been operating for about 4 years. And we are one of the biggest car sharing company today. And our operating system is basically just a simple application that anybody can download, register online from the app, and you can basically get from registration to driving in a span of 10 minutes. The app itself is pretty simple. It gives you an opportunity to view various cars that is available, and you can book them from as short as an hour to a span of 2 days. For the past 3 years that we have been operating, we have grown quite a fair bit. We started off with about 200 vehicles, and today we have more than 3,000 vehicles all over the island across 1,600 locations. That's how much we have grown, and with that as well, we have grown into a few challenges, which I will describe a little bit later. So this is what we started with. The GetGo application started off pretty simple. We have two applications running concurrently. We have the mobile app, which is what our users see, and we have what we call the customer management system. That is a backend system that is running for administration purposes. So this is also where we manage all bookings, manage our customers' details and stuff like that. So all of them are connected via a simple API, monolith stack, connected to a single database. And of course, with this, as we scaled, things started to grow awry pretty quickly as our compute systems were running out of memory, our database were running out of hand, every now and then. And we were looking for a solution, right? Specifically myself. And one of the dreams that I had was to rebuild the whole entire system into a microservice, and we eventually settled into event-driven architecture. So this is what I would say our 2.0 architecture would look like. Back then, a year in, I was researching on what can help with scaling our business. And at the architecture side, we were looking at how do we segregate our domains into services which are a little bit more specialized. And this is a simplistic structure of what it looks like, right? So we kind of broke up all our services separately into its own separate domains, and each of these domains is connected to a database. And what lies in between all of these services actually is an event broker. Of course, we've had multiple solutions that we were discovering, and we came down to Solus as a solution. So how do we go about doing this typically? So we had, I would say, a messaging strategy, right? And in order to do this, we were looking at how or what would each service consist of, and how does it connect to each one another. There were two solutions available, or rather, there were many solutions available. But at a PubSub level, we were looking at how do we connect each service and where do we connect each service in each of the request calls. And maybe PubSub is not the only solution. And we looked at two strategies that was available. One is, of course, PubSub as I would say, the backbone, and a gRPC that is another solution that we looked at, because this enables us to have inter-service calls, direct inter-service calls, which don't require multiple services all at once. So a good example would be one of our user services that talks to face recognition or face verification feature set that we had, which talks directly via gRPC instead of PubSub mechanism. So that's just one example. I can go on further, slightly deeper into this, and where do these architectures exist. So this is a typical, I would say, service that we have. One of the most critical services that we have. Of course, booking is one of the main functions. Any user or any customer that we have um, do book a vehicle, as I mentioned earlier, as part of the car sharing service, and they typically book an hour. And in that booking, they will look at vehicles in availability. And of course, we include certain things like promotions. And in that booking, they also have to make a payment, right, for the hours that they book. So in a typical strategy like this, where we have a single service that needs to connect to multiple services across the line, this is where we would use a PubSub strategy. So how it typically goes is the booking service is an orchestrator, and it would typically request other services or other information from the other services that is connected to pull in all these sorts of data. So in a typical call, for example, if I'm looking for a vehicle for today, for an hour, what the booking service will do is it will do a search, right, for all the available vehicles in that time span. And at the same time, it would also validate any promotions that comes with a booking. And from then on, it would connect then to the payment service, where the customer would then make a payment for the booking that they have reserved. And pretty much a booking happens in within a second or two, right? That's how fast it takes, even though we have multiple information running around in the request and then the reply format. Now, for um, for the other set of services, for example, when you log in, right? When you log into the application, what we typically do is we would check for your authentication token, and this is a direct service that talks to the user service, right? So from the login service, we talk to the user service. So it's a direct connection. Now, in these cases where there is just a one-to-one request and reply requirement, this is where we will use gRPC as a solution, right? So not everything has to connect to a PubSub architecture in our view. And the reason why we do this is because we don't want PubSub to be the single source of failure, if any, right? And we want to enable some level of independence between services to have some level of communication. And this kinds of brings about the loosely coupled mindset, right? So this is how we have broken up our service, and we have about 20 different services that's running all over the whole architecture, and we connect to external services quite largely as well. An example would be our fuel provider. We use EssoMobil as a fuel provider, and this is also another example where we use gRPC, where we connect directly to the services that they provide, and we basically just get a PIN code for our customers to pump petrol for the cars. So and as you guessed it, we pay for the petrols of every booking as well. So another added service for our customers. A little bit on security. As you know, re-architecturing a whole service and a whole business, security lies pretty prominently in part of our consideration. Reason is because we do collect some sensitive data like your personal particulars, as part of verifying your driver's licenses and stuff of that nature. So we do look quite deeply at security as part of how we build the architecture. One good thing about Solus as a solution is that we do have that lever to use Solus private cloud and not the public cloud as one of the features that they have. And this enables a small encapsulation of data set away from the public, I would say, access, right? And typically where we set up our private cloud as well, what we did was we have Solus as a private cloud where the service, where the PubSub service is running, and we have our own private cloud where all our services are running. And what we do is we typically do a VPC peering. We are running on AWS, and this helps us with the security in that sense, right? So all of this is running privately. There's no public access. And another part of security that we also try to establish is internally at the service level, right? So what you typically need for a service when you connect to a PubSub like Solus is authentication token, right? You need to authenticate to enable the publisher and the subscriber to have a connection. And one easy way to do this is to build and write that authentication token within the service. So we thought that that was a little bit dangerous because we have quite a fair bit of liability with our developers, and it is typically not safe to give your passwords to your developers directly. So what we did as a practice was to enable AWS Secrets Manager to withhold all of these tokens and passwords. And what we do at build time is that we retrieve all these tokens at build time before any of this is deployed. So that enables a little bit of I would say a shield from our own developers to know what is the token, what is the passwords, and what is the usernames, etc. For various, I would say, services that is connecting to other services. So um, Solus is just one of them, right? Or any other services that we connect to. For example, an external agency that we require, certain API calls. So this is typically the strategy that we use, and I think so far this has yielded us quite a safe set of results because tokens and passwords and usernames are pretty much obscured from anybody that works here. So the only people that will probably have access is myself and my highest senior management. So that's one strategy that we used, and I think it was quite useful for us. Okay, moving on next. So as you know, there's a few strategies in PubSub that you can employ, right? And we have the typical just publisher subscriber way of working. But when we were studying this strategy, or rather solution, we looked at it as something that every message is kind of crucial, right? And every API call cannot be missed out. And what was the only way to do this was to employ a queue, right? Because a queue is kind of a guaranteed message delivery from one service to the next. And it also manage the way that a message is received from the other side. And you can kind of replay this message from the queue. So this is one of the strategies that we use that really helps us a lot, because when there is a significant load coming through from any one of the services, the queue kind of manages the subscription kind of ascending, right? And this helps us with guaranteeing every call is a guaranteed call. and we are not missing out on any, I would say, messages or requests from one service to the next. And a typical call basically just gets sent no matter what. And I think at the DevOps level, we are pretty much secured. We are, we are not panicking at any moment in time because we know that this is a guaranteed delivery queue. We have also set up multiple ways of monitoring this. Tracing is one of them, and I would say it is pretty easy to set up, and you can typically see on a day-to-day basis if you put up your charts the performance of the system quite easily, given that we have quite a robust, I would say, architecture with all the services running all at one shot. So yes, this is why we use the queue instead of just running it purely as a pub/sub solution. Now, maybe I'll just like to add in what were the challenges that we had employing this. I don't have a huge staff. Uh, I only have like maybe a set of 20 developers on hand till today. And at the start, when we were embarking on this journey, we typically had just 4 senior developers or senior engineers that we employed, and they were the first few ones that basically rebuilt the architecture. So when we onboarded the rest of the developers in, there were some familiarity issues, and they had a little bit of a learning curve. But that was, I think, quickly overcome because the solution was quite easily understood, and we had a good working relationship with our partners in Solus when they came over and give us quite a fair bit of tutelage, some guiding principles, and it led us to understand the onboarding journey and how to implement this solution quite quickly, right? Another thing that we also employ within the architecture or as part of our engineering principles is the use of automation, right? What do I mean by automation? There's a few automation solution that we use. One is building automation, right, which is quite basic. But another thing that I would like to also highlight is the fact that we do quite a fair bit of QA automation, right? QA automation is yeah, it could be something that everybody does as well. But I think with an event-driven architecture such as ours, it can be quite tricky simply because there were multiple services that we had to test. And beyond just testing within a service, we had to also test end to end, right? And when that happens, there's a typical I would say culture of understanding that needs to happen first and how the whole architecture works. And this is not typically with the platform or the solution. It is just how event-driven architecture works, right? And we have till today about more than 5,000 automation test cases that is running almost on a daily basis overnight on a regression mode. And this took us maybe a fair bit of about a quarter to really understand, and another maybe 6 months to fully employ. So it was tricky. It was a tricky journey, but we got there. We got it running. The other few, I guess the other point I would also like to highlight is that monitoring is important, right? And observability and monitoring is super important, especially in an architecture that is as big as this. As much as it is quite ironic that you want to make it simple, where you look at a service as a typical functional use case or typical domain. But when you connect everything together, it can become quite complex. So monitoring is indeed something that we really had to push hard, and the team had to push hard to get up and running. And why this is important is because it gives us some level of service uptime. And at the very start, when we built this architecture and we released it a little bit on the beta side with a small group of users, it helped us a lot with troubleshooting, right? And we could see exactly and trace every message um, down to the origin, and this helped us to really troubleshoot service at the service level, as well as the whole, even the down to the API calls directly. So this was, I would say, a challenge that we kind of overcame. Uh, and lastly is, of course, security. As I've mentioned earlier, I think it should be one of the key drivers as part of your consideration if you're rebuilding an architecture, and it has to be planned ahead of time. And I typically remember doing this with my senior management, senior engineers, and had multiple sessions just sitting down and talking through security, um, and ensuring that we don't have any gaps. And another thing that we also did as to cover on the security gap is to do a full-scale architecture review uh, prior to main release. So that helped us a lot to give us that assurance that, hey, we are running it safe. Yes. Now, so maybe some accomplishments that I would like to just shout out is that we kind of rebuilt the whole architecture in a span of 8 months, and this is full scale 8 months of no feature development work. We had to really focus into the architecture, and I think it was an investment. Right, there are definitely a few ways which you can do architecture build. One of it is to chew on it bit by bit, but we took it as a challenge. And I think from the way that we run our business, because it was still small and we were still scaling, I think it was quite a strategic move to decide to make this an investment as part of the business, right? We spent another 3 months testing, and this involved the whole technology team testing together with our business users as well. So we kind of really rebuilt everything from scratch and had to run all the testing again, just to make sure that the system works as intended. And all of this while running the monolith at the side, right? So it was quite an interesting time where we had to juggle between one project versus one huge project versus a live environment. Um, so as I mentioned earlier, we also built a new automation testing stack, um, with more than 10,000 cases today. So there's quite a fair bit of test cases across services, across end-to-end API calls. So this has helped us with multiple feature releases as well. And I think to date we just released last June. I think we have released maybe around 5 or 6 different features, and the test cases really helped us to give us that level of assurance that nothing is broken before we make that eventual release. So I guess another accomplishment that we did was we managed to run a month of beta without any issues, and thanks to some of the principles that we practiced with testing and with the thorough look at security and stuff of that nature. And we also launched the main release with almost zero incidents, right? I would say typically zero incidents. The only incidents that we have was, manual on the ground kind of issues, which is a typical day-to-day kind of thing. So I think this pretty much sums up our journey. I know it's a little bit short, but hey, I hope everybody gets a gist of how we managed to do this in a span of 8 months with an event-driven architecture that is quite complex and huge to begin with. And that's the end.